Hello, everybody. This is Pete Morris for Thursday Zoom. It is November 5th, and we have a terrific thing going on tonight with Robert Lenert telling us about ADSB, uh, the uses and care of the equipment and the process. We also are going to be talking about some other things too. I would like to, just for the short time here, share what the program looks like. Here it is, just so you can see it in the recording. And this tonight is also available as a Wings program. So there, this is how you do the Wings. Go to northeastcomanche.org, go to the Comanche Zoom page there, and partway down the page is the registration link. You need to be registered to get the Wings credit. What we need is your name and an identifiable name for you when you're on the Zoom, and your email address. If you come in as iPad something, that won't help. So please rename yourself to be able to use the Wings credit. And at this point, I'm going to shut up and start admitting people. And CJ, you can do your who are you, where are you, and what should fly routine.
You're doing a semester abroad? Alrighty, hey. Well, so hi everybody. I'm guessing most of the country is still glued to the television to try to figure out whether we have a new president, or rather which one it is. But we are here tonight, and so yeah, so say who you are, where you are, and what you fly. And I will say that I'm CJ, and normally I'm in Vermont flying 180, or in Westerly, Rhode Island, flying the family 260B, but right now I'm kind of stuck in Texas, and this is a topic near and dear to my heart. So the 180 and I are here. It's running great. We just have a couple of questions about transponders and stuff like that. So please jump in to any quiet spot, say who you are, where you are, and what you fly.
Okay, Dan Homiser in Kenosha, Wisconsin. Comanche 250, and as of a couple weeks ago, it's a hangar queen. So I'm in the middle of, I just got the motor pulled off. My cam is shot, so it's time for an overhaul.
Dan, can I just jump in and recommend a shop called Dual Engines in I think MO. I think, I'm not sure if that's Missouri or Montana.
Missouri. Yeah.
Yeah, it's a lovely shop. My friend used them, and the prices are insanely low on shop price. I think the chap just runs it because he's bored rather than for make any money. It's my friend's engines run like an absolute dream coming from there. Wow. And it cost him about 23 grand.
Jewel?
Yes, that's correct.
Jewel. All right, I'll take a look at it.
Go ahead, you can unmute yourselves and talk. Go for it.
Ed Cullen from South Lake, Texas, Comanche 250, 1961.
Hi everyone, I'm Adam Height. I'm from the UK, and I'm entirely confused as to which Comanche I fly, as I've got loads that I'm trying to buy.
Ernie James, Southern California, Yucca Valley, 65, 260.
Don Pitts, Lovington, New Mexico. I've got a 66 260B.
I'm Mike Newman from Western Pennsylvania, and I fly a Comanche 250 in 1959, 6050 Papa. And I'm from Western Pennsylvania, north of Pittsburgh, Butler, PA.
Hello, everybody. It's my first time on. I'm Galen Northcutt from Nashville, Tennessee, by a 260B 9077 Papa.
Welcome.
I think I had myself on mute. James Coleman from Harbor Springs, Michigan, which is the upper part of the Lower Peninsula. I've got a 1965 400 model, November 400 Golf Charlie.
I'll mention again that I'm seeing some names on here, like, Edwards iPad 2, for instance. If you are looking to get Wings credit, we need to know who you are. And the best way to do that is to rename yourself so we have a good idea who you are.
And Pete, don't they also have to include the email that they have registered
Right.
onto FAAsafety.gov?
Yes, we have the emails when you register with the form, you get it, the email. The problem that Robert Klein has is when you log in here on Zoom as iPad number 3, he doesn't know who that is. So that's why we did, like, for instance, there is somebody who is logged on right now as iPad. And there's an iPad 2.
Or Piper Comanche?
Piper Comanche, we know who that is.
Okay.
Yep.
Now that we don't know who that is.
That's me. I was on the wrong side of the house to try to get internet. So
CJ, you want me to rename you?
You should rename me. Yep. I'm in the process of moving to a place where I've got good internet access, and so that should work better.
I just
Rich
took
testing.
the, oh, sorry.
Rich testing.
Okay.
Thank you.
Hey, Rich. All righty.
I took the plane in for annual today and talked with the guys about the Genesis S-Tech 3100. I guess they're doing some flight testing right now, expecting to have everything done and start shipping units in January. So we've got a tentative date for the end of January to get the 3100 installed in the 400.
That's amazing news.
I'm Pete
Pretty
Morris. I'm
exciting.
in Connecticut, and I just had a couple of interesting days just now. We have had problems with the fuel gauge, in fact, not even moving, knowing that the tank is halfway empty and it still reads full. We took everything apart and found out that every single one of the floats, the brass floats, had fuel in them. They sunk. And then we also found that one of the wires, one wing, in fact, the wires were reversed, so that the ground was trying to tell the gauge rather than the sender. So you'll be happy to know we figured it all out, and actually everything works for the first time. Everything works.
It's really interesting that you bring up fuel gauges, Pete, because I had a scary experience with some fuel gauges on Tuesday as well. I was flying a 182 and the fuel gauges were calibrated for standard tanks, despite the plane having long-range tanks fitted. And I ended up having a small panic attack as I thought I had only had 5 gallons of fuel left while I was at 6,000 feet. But turns out we actually had about 20.
Well, it was good that you were at 6,000 feet.
Well, yes and no.
Okay, who are you?
It
Where are
gave
you?
you a
What are
whole
flying?
new chance. And what's your glide slope ratio?
With a 182, take a brick and fill it with lead, and you might get around what a 182 will do.
Oh dear.
I was quite far out to sea in the over the North Sea as well, so it was an all-round not experience I would never recommend.
Well, glad to still have you with us. Glad it was an error and not a actual emergency.
Well, it was only burning from according to the fuel gauges, only the right tank was burning, even though the fuel selector was on both. And when I switched it to left, it continued to burn from the right tank. Eventually, I managed to switch the fuel gauge enough that the fuel tank enough that it started to burn. But it was a very frightening experience for my first long distance flight.
Oh boy.
Yeah, not a good way to get around the world.
Pete or CJ, I have a question. We thought last month or last week, we talked about the looking for a trunnion for to get some analysis done on it. Was anybody successful in finding one?
Yes. So we've got several on their way to Sunny. And let's see, actually we have several committed to go on their way to Sunny. I've got one late twin trunnion that needs to have the bearing pressed out before it's being sent out. And then we've got two people sourcing the right alloy, the one that's stronger. It's a new alloy that's much stronger and has higher stress corrosion resistance. So that is underway. And then we've got two shops confirmed that they can potentially make them. You know, they have the right equipment. And I've got a third twin Comanche owner that happens to make landing gear for other types of aircraft that I need. It's on my Rolodex to call. They're in. Looks like it might actually happen. We create the test one. One shop has is got an entire machine shop that's been in existence for about 30 years. And they're looking for the ends. In other words, they do these huge 20-foot slabs of the special kind of aluminum. And they said, if you can get the tail ends that are cut off, because we don't need a very big piece, they're much cheaper. So he's got his guys looking for a source that's those heat treated type and super strong. So yeah, stay tuned.
Okay. Here.
Can I suggest that if that is happening, if you see anyone about to buy those $14,000 Australian ones from Johnson, maybe let them know that there is something in the works. So there's no need to unless it's really urgent.
Yeah, we don't want to say anything unless we've really got something pretty solid.
Exactly.
As much as that's a horrible price, it's really good to have choices. And so, you know, you're right, but say to them there is some stuff coming in the works if they've got a little bit of time. And the other thing that's in the works is potentially a repair. A DER.
Good time to be a Comanche owner.
Repair process. So we will see.
Okay, I'm going to share this.
Let's get it done first, then we can celebrate.
This other PowerPoint thing. You can go ahead and still talk and whatever, but this is what we're doing for our public announcement kind of stuff. So go ahead and talk, read while you're at it.
Hi, this is Bernie Poland. I'm in Southwest Florida right now. And I've got a PA 39 and probably heading back to Michigan on Saturday.
Bernie, welcome. And PA 39 is beautiful. So thanks for being here. Another long cross country in a Comanche.
Yeah, lots of them. I go back and forth nowadays.
No kidding. Do you, you're going back to where again, Bernie?
I'm going back just north of Detroit, Pontiac, Michigan.
Okay. You and Eric Jones, I don't know if you know each other, but you guys are doing similar trips pretty frequently. And there are a few other Comanche drivers as well.
I do not know him.
Okay. If you are able to put a note into the chat window, I can introduce you guys if you'd like. Never hurts to have another Comanche driver doing the same back and forth route. And welcome. Thanks for being here. No. So he's in a turbo 260C. So you guys are both late model. And anybody else, say who you are, where you are, and what you fly.
This is Rich. I had an interesting chat with my oldest son-in-law this past weekend. He is the head of robotics for Luxottica in Southern California, which is Oakley. And on his home computer, he has one of the most wildest design systems I've ever seen. Solid Air, I think, is what it is. It was what Boeing used to use, and then they switched over to something else. But he says if we can get one, he knows people that are outside. He can't do it at work, obviously, but he knows people that are outside that can do the 3D scan down to what we need it if we can get one. So we'll see how it goes. He didn't promise me anything, but he said that I basically show, okay. So they pay him enough to know that kind of stuff. And he's been in prosthesis and everything. And he's a real bright kid. No, he's not a kid, he's in the late 40s. But I'm looking at it, and I'm looking at it for a few other things too. But this came up, and we talked about it. And as you design and as you put the stuff in, you select what material it have with the appropriate loading and all of that kind of stuff like that, and it'll tell you what the best stuff is. This is one program. This is one hell of a program. I was really impressed.
It sounds like it. Can you put your note, Rich, into the chat window also with a note that says laser scanning and materials analysis?
Was that using
I did it
SolidWorks?
myself. Yeah, I will, and I'll bang it in there at some point. Like I said, I don't know how far this is going to go, but I got this. But he showed me basically what goes on, and it'll give you all your load stuff and all the significant data that FAA needs. You still have to make one and go through all the DER and DAR stuff. But if it's that easy, well, nothing about this is going to be easy. We might also have a better way to do the stabilator yokes too. So significant cheaper than the Australian ones. And I have to still do that to my plane. I've still got all of my 100 hours.
That would be great. Yeah, put a note in there and I will reach out to you. Sonny Monco is also offered to do that. And so having both of you available, because that was one of the things we had a strut housing sent out several months ago for scanning and to be put into, I think it was SolidWorks. And it was, a shop that was like, I can do this as a favor. They've been super busy and haven't been able to. And so if we can have them send that strut housing to is it your son? That would be a real help coordinate that.
I thought I'd mention real quick, all of these Zooms are being recorded.
Well, say who you are, where you are, what you fly, and
all these Zooms are being recorded. You can go back and look at them later. We also save the chat text. So if something is in the chat text that you want to share, or if you want to go back and look at, that can be found also.
I'm Wayne Smith. I fly a Comanche 180 out of Rochester, New York. Good to be here.
It's interesting to hear someone is from New York. That's where I'm going to be soon.
John Futter, 1969 260C, Orange, Massachusetts.
Jim Brown, I have a Comanche 180 in 1959, and I'm in Detroit, Michigan.
Hi, I'm Bill Knapp.
Are you flying out of Detroit or one of the airports around the area?
My plane's over at Willow Run, which is to the west of Detroit.
Yep, I'm at Pontiac.
Oh, all right.
Eric Jones is here from Wisconsin. We might have some.
Everybody, it
we
looks
might
like
have
my
some
connection
late
is
people.
bouncing.
We might have some late people coming in because I just landed, so there was some pretty good winds.
Welcome, Eric, and good to have you. Headwinds, tailwinds, or otherwise.
What part of Wisconsin is that?
I fly out of Burlington, just west of Milwaukee.
Oh yeah, yeah.
Eric, your name just came up because you and another gentleman flying a PA-39 back and forth between Florida and the Wisconsin area, or in his case, just north of Detroit. And I said, oh, Eric Jones, I need to introduce you. So unfortunately, my Zoom connection just bounced, which terminates my chat record. And I'm terrible with names, but the person who's flying the PA-39, this is Eric Jones, the person who's coming up as E.
The chap's name is Bernie Pollen.
Yep.
Very good,
So Bernie,
Adam.
here's Eric.
Yep.
Good on you,
Hi,
Bob.
Eric. This is Bernie. I'm flying a PA-39 out of Pontiac, Michigan, and I fly down
Where do you
to
fly?
Fort Myers, Page Field.
Oh, okay. Yeah, I fly into St. Pete, Clearwater area, but I'm actually, in fact, I just lost out. I tried to buy a home out on at Buckingham, and I failed in Fort Myers.
There will be more.
Not Bernie.
Yeah, there'll be more, but I like that one. It had a 4,000-foot hangar.
Ah.
Oh my.
Hey, Eric.
That would be.
Yeah.
There's another Comanche on Burlington. I don't know if you're familiar with. There can't be too many. It's a single, and I think it's a 250. Are you maybe familiar with that airplane?
I didn't know that there was another Comanche at Burlington, to be honest.
Okay, I saw it in a hangar one day, and it had some stuff.
Well, it could be in a hangar and not flying. There's a few of those around Southeast Wisconsin.
Yeah, okay, which is possible. The door was open, so I just assumed it was flyable. But I was just kind of curious if you were familiar with that one. There was some work done to it that some I'm not sure if I'll say mods, but I was kind of curious about. But if you're not familiar with it, it's a moot point.
I'll ask around which one it is, but because if there is one, I got to find out who it is, because right now I don't, and I've been there for 15 years.
It was in a hangar about midfield. Well, that's a lot of hangars.
On the west side or on the east side?
On the I was about to say north side.
Is it
turned around?
Well, it's on the north side, but there's a new group of hangars down on the west side, west of the grass run strip or east of the grass.
Almost positive it's west of the grass strip, on the same side as the gas pumps, west of the grass strip. Does that make any sense?
Yeah. I mean, the older they look old on the east side. They look brand new on the west side.
Okay.
But I'll figure it out.
Yeah.
Eric, did you say Buckingham is in Buckingham Air Park in Florida?
Buckingham Air Park in Florida, yeah.
There's
It's,
an
Fort
abandoned.
Myers.
There's an abandoned 250 in the hangar just off the end of the runway at Buckingham.
Yeah, I knew that. Yep.
I couldn't get it off the owner.
We got about 5 minutes till the presentation starts, people.
I was going to say, this is why we call it hangar flying. Perfect example. Hey, if you're here, feel free to jump in. First of all, thanks for being here and not being completely involved in this presidential whatever it is that's going on for days. So welcome, and just say who you are, where you are, and what you fly. Any questions?
Jim Peters, Brisbane, Australia, PA-30B, 2,500 hours total.
Oh, Jim, it is always a pleasure to have you on. Thanks for being here with us tonight. It's good to see you.
Yeah. What's your time scale on the legs? on the undercarriage? Do you think?
Well,
Estimated time of arrival.
for the undercarriage legs, I
Yeah.
am going to have to. I'm going to have to say I honestly don't know at the moment. But what I can say is we have all of the people together that seem to need to cooperate to do that. We have the machine shops. We have with the extra deep CNC milling machines. We have 2 people now with the laser scanning connecting to the materials analysis drawings programs. And then we have a DER willing to do the analysis needed to confirm that recreation of the Piper trunnions with the much stronger materials will work. We've been going back and forth for the last week on with the machine shops and with the person who recommended this particular material to confirm that it will work, and it looks good so far.
Well, they're the knowns. The unknown is the administrative time delay.
Yes, for sure. The thing that might make this viable, and here it's nice that we have Rob Lenert here, because although, Rob, I don't think this is necessarily your total area, but if a DER does the engineering analysis, and this one has an unlimited sign off for non-life limited structures, as well as I think it's called materials or the stuff you make things out of. Is that then available to install under a 337 while we try to get the more broad approval? Do you happen to know, Rob?
You mean as an owner produced part?
Yep, as an owner produced part. With the materials analysis and the structural analysis that this DER is authorized to do. Those happen to be his 2 areas. He also happens to be a twin Comanche expert. That's his interest.
CJ, I can do some research on it, but I've not dealt with owner produced parts in any detail or ran anything any of them through the approval process. If there is, I'm not even sure. I remember that on a previous Comanche Zoom I was on, you had a couple guys that were very experienced with owner produced parts, and they'd probably be the best resource to get that information from.
Yeah, we do have an owner produced part. I think that is what it's going to be. So, Jim, to finish answering the question, the plan is to produce a sample and then subject it to the sort of what's a standard of care kind of analysis that you do to make sure that there's the proper strength, that there's the proper corrosion resistance, et cetera. And I believe that required testing has to happen. We will be putting out a request to support the time to get this done. We've got a whole lot of people donating machines and material, and the one on the DER side, although he's done, I think, tens of thousands of dollars of work for free and is willing to keep doing so, I finally said, how do we get to the front of the queue? And he said, well, it is how I make my living. So when a paying job comes in, the Comanches go, on the back burner until I can get the paying job done, and I go back to what you're doing. And I said, and I did a quick analysis, and I said, I think the cost to us has been over $800,000. It was a related matter. So what would it cost for us to get to be one of your paying jobs? And he said, well, and he gave me a surprisingly modest number. So once we have that project, once this project plan is solidified, we'll come back to the Comanche community and say, would you like to finance these 2 initiatives? It looks like it'll save all of us this much money, and then just see how the community responds. Does that seem reasonable? We're very close to being able to do that, by the way, Jim. But it looks like that's going to be the best way to do it. Does that answer the question?
Sounds like there's too many variables to give any sort of number at all.
Yep, I think that's right, but I don't think I think we're more like a week or at most 2 weeks from being able to give you that number and that time frame.
Okay. What about the spring? What about the spring instead of the bungees? Is anyone going to work on that? Do you think that's a viable option?
I do. The bungees are so cheap right now that we hadn't put it as a priority, but I think it's very viable. I mean, several people jumped in and said, you know, we've really thought this might work. And again, the same DER that raised it last week is the one that can do the analysis to say, yes, this will work. And he's the one that did the analysis of the bungees. So he's got all the data right there.
Well, the aim will be to reduce the number of interventions on, you know, the number of times you've got to change bungees or change springs, isn't it? Really?
You know, that's a good point. And we haven't really looked at any excess stress that's put onto those what have turned out to be relatively delicate areas. So Jim, that's a good point. I hadn't thought of that. I'll send a text over and raise that now.
Unless the life of the springs is a lot longer than the bungees, it's probably not worth doing it.
Mm-hmm. Yep. Yes. Well, the springs would be much longer lifetime for sure. And I am now talking over. I think I'm talking over the beginning. So I'm going to be quiet now. But Jim, I'm so glad you asked these questions because they're timely and relevant. So keep asking them.
Okay.
Yeah, GJ is right. We're at that point where we're going to start the presentation. Tonight is Rob Lenert, and everything you ever want to know, basically, about ADSB. There's a lot of stuff, a lot of questions about it. There's a lot of information available on the websites and stuff like that. But the main thing is that we all, particularly in the areas around the bigger airports, we need to have it. And there is also the potential of down the road, it becoming much more required because it may, in fact, at some point replace radar in terms of guiding aircraft. Not replace totally, but, you know, take the place of. So with that, I'm going to hand it over to Rob Lenert.
Hello, everyone. I'm going to share my screen.
I would suggest everybody goes to the speaker view. That way you can see him and the screen nicely.
Okay, you should be seeing my screen now. Is that working?
Yep.
Yep.
Okay, and it should have a pointer there. Okay. Anyway, my name is Rob Lenert. I'm the Bradley FSDO, which is in Enfield, Connecticut, FAA Safety Team Program Manager. My background is before the FAA, I did 6 years in the Navy as an aviation fire control technician, worked on the heads-up display system and the data process and a couple weapons delivery computers in the A-7E Corsair. After I got out of the Navy in 1980, I moved up here to New England and started working in avionics and general aviation aircraft. And was working in that until, let's see, 2012 in that industry as first a technician and then an avionics manager or accountable manager for repair station, where we installed a lot of aircraft. I mean, a lot of avionics systems in aircraft, whether it be autopilot or audio systems or communication, navigation systems in aircraft, and really enjoyed that work and really had a good time doing that. And then joined the FAA just over 7 years ago and have been with them since. And now I'm the FAA Safety Team Program Manager. Before that, I was an aviation safety inspector involved with the duties that are involved with that, anything from investigating accidents to performing or approving letters of authorization for international operations on heavy commercial jets to working with commercial operators and repair stations in our district. I really love what I do. I really love promoting aviation safety, and I'm counting a privilege tonight to be here with you to share about ADSB from our FAA perspective. I am an airworthiness guy or a maintenance type technician guy. That's my background. So I do have some time flying. I'm not a pilot, but I've got probably, conservatively, probably 800 hours in the air working on certification of GPS systems when it was required. And then also testing and fixing autopilot systems and making sure they work right when we were done with the work. Haven't flown much since I've joined the FAA, but again, it's great to be here. Let's dig into this. If any of you are pilots, and especially as I'm going through the airspace portion of this, and you want to, correct me if I said something wrong, which is definitely a possibility, or have some more input, please interject, and I welcome that. So let's go ahead and get started. We're going to talk tonight about ADS-B surveillance. I know it's titled for aviation maintenance technicians because I redid this latest version and retitled it as such, given the short term of coming on with you tonight, and I didn't have time to change it. But so tonight, want to talk about this link right here. You can do a print screen. If you've got an Apple computer, I believe it's control print screen. If you've got a Windows computer, I believe it's the Windows button and print screen button. And I believe that Zoom also has the ability to print screen. Isn't that right, Pete? Do you recall?
So this is all being recorded anyhow, so you can always go back and look at it.
Okay, good point. Thank you, Pete. So we're going to look at ADS-B subjects. We're going to look at rules in airspace, system and services, avionics capabilities and equipment, installation issues that have been observed, and information about installations, the maintenance for ADS-B systems, and some of the web resources that are available to us. First, we're going to dive into ADS-B rules in airspace. The rules are 91.225, 14 CFR part 91.225 talks about the ADS-B equipment requirements, and 91.227 talks about the performance requirements. I'm sorry, I did mess up. 91.225 is about the applicable airspace for ADS-B. If you look at that, it's pretty detailed. And then this is the performance requirements of ADS-B systems, the FAA performance requirements. This rule applies to all aircraft operating in rural airspace, including foreign registered aircraft, except the following aircraft. That is, aircraft not originally certified with an electrical system, or not subsequently certified with such a system installed, and that includes balloons and gliders. In 91.225, also subpart F, it states that once an ADS-B system is installed, it must be on at all times. Must be on at all times. I know, Pete, we discussed earlier about having it shut off in your aircraft, and that's normally something that shouldn't be allowed. Normally, when you hit your avionics bus, your ADS-B system should be on, even on the ground, because it's utilized, especially large airports on the ground. It's important that your ADS-B system be on all the time if it's installed. That's a rule. It's not a option. And see, it says when the aircraft is moving under its own power or per local airport procedures when under tow and movement areas. So even at some of these larger airports, you're required to have your ADS-B on when maintenance is towing it around. So let's take a look at the airspace here. These are the required areas where ADS-B is required. Up here is class airspace, which is above 18,000 feet, mean sea level. And class E is between 10,000 MSL and above ADS-B required space. And then here's class E airspace, which is 12 miles out from the coastline in the Gulf of Mexico, from 3,000 to 10,000 feet. All your class airspace, class C airspace up to 10,000, class B up to 10,000, and then the mode see veil around any of these areas, which is depicted by this outer ring here. This is a map of the United States of the ADS-B out airspace below 10,000 feet. I think that's 10,000 feet, MSL. As you can see, some of the areas like we're up here in New England, it's along the East Coast, it's pretty well congested, and there's some areas over here in California where it's required, but you can see there's a lot of space where it's not required. This is an ADS-B program you can load onto Google Earth, which is a 3D depiction of the airspace rules, and a means by which you can, sort of check to see if you're flying in their, ADS-B airspace. As I mentioned earlier, ADS-B is required in most controlled airspace, including airspace within the Mode C veils. So even though you got your controlled space, the Mode C veil is required area for ADS-B. You guys got any questions about the airspace before we move on? No questions? Everybody all set?
Yep.
How about some feedback? Does everybody understand that clearly?
Yep. I'll have a question later, Rob,
Okay.
about what happens if you've had a successful ADS-B installation and then components of your ADS-B installation fail, because I have a feeling I'm not the only person in the world that's ever going to end up in the situation I'm in now.
Very good. We'll be we'll be covering that in a little bit.
Perfect.
Yeah. So don't fail the veil, it says up there. So we're going to talk about ADS-B systems, how it works, and their services. ADS-B stands for Automatic Dependent Surveillance Broadcast. Okay. It's automatic because it transmits the location and other information every second, versus a transponder that is every 5 to 12 seconds, depending upon how far you are away from the radar site that you're being covered by. And there's no pilot action required. It's to be on all the time. It's dependent on the aircraft being equipped with a rule compliant GPS, or a WAAS GPS, as we are familiar with. Surveillance, ADS-B is a method of determining position of equipped aircraft, vehicles, or other assets. It allows you to be seen. It is broadcast the aircraft's position and transmits tracking data and more to controllers and to aircraft equipped to receive ADS-B. ADS-B targets display in near real time and do not degrade with distance or terrain, unlike radar systems. So let's take a look at this system. There's a lot happening here. You've got a GPS constellation up here. You've got a couple GPSs that are sending position information down to your 1090 extended squitter equipped aircraft, which are typically your larger jet, or those aircraft that are operating above 18,000 feet MSL. And then you've got the UAT equipped aircraft that are those that are operating. Thank you.
Sorry, Rob, I keep hitting that by mistake.
Okay, no problem. Okay, so satellite position is pushed into or received by your aircraft, whether it's UAT or 1090 ES. The 1090 ES system operates aircraft to aircraft, and it sends its information to the ADS-B radio stations. The same with UAT equipped aircraft. And then those radio stations transmit this information to air traffic control. So why is ADS-B technology better for the country? Radar surveillance, versus surveillance based on GPS information. It's a better airspace utilization, better coverage, and lower infrastructure installation and maintenance costs. A service volume, the term service volume is defined as a volume of airspace within which ADS-B services, such as traffic and weather information, are available. Here's a coverage map for all the ground stations throughout the US. And this area out here represents the coverage area for these systems throughout the US, Hawaii, Alaska. And that's, let's see, the altitude that it picks it up at, I think it's 5,000 feet below. It may be lower than that, to 3,000 feet, I think. Here is a depiction of the coverage, ADS-B coverage and radar coverage areas up here in New England, as we're familiar with. And this is for 3,000 feet AGL. The dark green is the radar coverage throughout here by the radar systems. Okay. And ADS-B coverage is almost complete throughout here, even in the light green depicted. So there's a couple areas right here that are brown, and over in here, other than that, everything else is covered. And then at 5,000 feet AGL, you can see that both radars extended further, and those brown areas are gone over here. And there's no gaps in ADS-B coverage. So you got your GPS. So that we're looking at the aircraft system itself that's feeding information to the ADS-B. You've got an ADS-B antenna that both on top and bottom in some aircraft, on your larger aircraft. On the 1090 ES equipped aircraft, they have what they call diversity transponders. A diversity transponder that is a transponder that has an antenna on the top of the aircraft, the fuselage, and on the bottom. And that way there's no shadowing that takes place for this aircraft being seen by aircraft that are above it. And it's also used in areas out over the ocean where the satellite-based ADS-B is utilized. And we're going to talk about that in a little bit. Anyway, so information comes in from the GPS to the ADS-B equipment. It's looking at the heading. The pilot input would be your mode C, mode A codes that you've selected in the transponder. Things like TCAS status, if you had a TCAS system in the aircraft, air to ground status, your barometric altitude from your altitude encoder gets fed into it. And the ADS-B gathers this information and puts it out in the data stream out the ADS-B antenna. So we're going to look at the frequency options that you have. Let's start off by climbing high. So at 18,000, flight level 180 and above, Class A airspace, 18,000 feet, you must have 1090 ES equipped aircraft. And you may also have UAT equipped aircraft. UAT is operating at 978 megahertz. And the UAT stands for Universal Access Transmitter. And then below 18,000, excuse me, I don't know if this is right here. You may have 1090 ES or UAT. It shouldn't be must have. It may have 1090 ES or UAT below 18,000 feet. But in order to operate in those ADS-B airspace, you must have that equipped, unless you meet some of the, if you meet the requirements of for the aircraft configuration, where you don't have an electrical system in the aircraft or the balloon or the paraglider, and that's not required. Okay, so one of the questions I had was, how does UAT equipped aircraft, universal access transmitter aircraft operating at 978 megahertz, communicate to an aircraft that's equipped with 1090 ES? How do the smaller planes talk to the larger airplanes? And the answer is ADS rebroadcast or ADSR. And what happens is that the signals for each are transmitted down to the ADS-B ground stations, and then they retransmit the information in the format that's compatible with the receivers in each of these, and that's how they talk to one another. So it's ADS rebroadcast.
Quick question there, Robert.
Yes.
How much time does it take for this transfer?
I believe it's in microseconds, Pete. It's not like it's
basically instantaneous.
It's not like it's seconds of difference. It's
not like
effectively
NextRad radar,
yes.
which is it could be like 6 minutes old.
Correct. That's correct. No, it's not that.
Thank you.
It's not instant, but it's practically speaking instant. Yes. The processing of the data is almost instant. It's just like the information from the GPS, the signal received from the GPS, and the aircraft information as far as position and velocity. It has to be updated. The WAS receiver is updated, I think it's 5 times a second. And then you can't have any delay in the processing, or very minimal delay on the processing of that signal and output. So you don't have any appreciable delay between where the actual aircraft is and where it's transmitted signals saying it is. You know what I mean? It's near real time. So next we want to talk about Flight Information Service Broadcast, or FSB. Now, is FSB something that's is only works over UAT frequency, or does it work on 1090 ES? Does anybody know that question? Does it work? So if you've got an aircraft that's equipped with 1090 ES, are you going to see FSB? The answer is no, you're not going to see it. It's only equipped with, it's only available with aircraft that are equipped with the universal access transmitters, or that 978 megahertz.
Oh.
So if you've got a 1090 megahertz or 1090 extended squitter or ES equipped ADS-B system, it will not pick up FSB.
Ah. I have a question regarding that.
Yes.
Unless you're going to cover it later, but I had the Cirrus weather downlink, which the resolution is really good, and I canceled that subscription and went to the weather that this gave me.
Right.
And after a summer, I went back because the resolution is just terrible. Is there a reason for that, or is there something down the road that maybe it's going to get better, or do you know what I'm talking about?
I do know exactly what you're talking about, and it's a matter of money.
Okay.
The system was paid for by the government, and I believe it's got a 5-mile resolution rather than the 1-mile resolution that the radar that you were talking about.
Yeah.
NextRad is much. It's got 5 times better resolution. But the same thing with FSB and NextRad weather. Because of its delays, it's not really for tactical planning. It's more for strategic planning, looking out way ahead. There's no way that NextRad should be used for tactical flying. I mean, if you've got a twin-engine aircraft or a single-engine aircraft with a pod out in the wing for radar,
Right.
You know, radar is real time. You know, as that scans, it's showing a real depiction of your moisture, you know, in the air. Whereas NexRad is, you know, got its, you know, 5-6 minute delay or maybe even more.
Even more.
The information that you're seeing as a pilot. You know. And that's just the fact of the, you know, the way it's processed, and there's no way to get around that at this time that I'm aware of.
So and I don't remember really paying attention. The FSB provided weather. You're saying that's quicker?
No. It's
So
it's
there's
going
still
to
a
have the
delay.
same delays. Same
Okay.
delays as
All
what
right.
you're seeing.
Yeah. All right.
You know, and some of the products are have a refresh rate that's slower than the NexRad radar. You know what I mean? Some of these other products that you know, your airmets aren't. You know, they may be depending on when they were updated and where you're at. You know, in the time frame, it may be later than that.
Okay. Yeah.
So again, it's good for strategic planning, not good for tactical decision making. You know.
All right.
The FAA continually evaluates FSB to determine opportunities for enhancements. In 2018, they added lightning, turbulence, cloud tops, icing, graphical airmets, and center weather advisory, and the data is available and provided only for the CONUS region. As far as timing, the lightning strikes updated every 5 minutes, turbulence intensity uplinked every 15 minutes, cloud tops are updated every 15 minutes, icing raster images delivered every 15 minutes, graphical airmets are uplinked every 5 minutes, center weather advisories uplinked every 10 minutes. Just to give you an idea of the time frame that these things and cycles that these things are brought to you or displayed in the cockpit. Please note that FSB information, including weather information, notams, and TFR areas are intended only for advisory use for the sole purpose of assisting in long and near-term planning and decision-making. The system lacks sufficient resolution and updating capability necessary for tactical aerial maneuvering around localized weather phenomena. In particular, in extreme scenarios, the oldest weather radar data on the display can be up to 15 to 20 minutes older than the display age that you would see on a radar. And also, FSB information must not be used in lieu of a standard pre-flight briefing. So the other thing that I had questions about is how do aircraft that don't have ADS-B, how are they seen in the ADS-B system? And the answer is TISB, Traffic Information Service Broadcast. So how that works, you've got, you know, the GPS system is communicating position information to the 1090 extended squitter and the UAT equipped aircraft. And then you've got aircraft that don't have ADS-B that are picked up on the radar system. And TISB will retransmit their position information to these aircraft that are getting ADS-B information. Is that clear to everybody?
Yeah.
Got it? Okay. So there's TISB is got its limitations, okay? Because of the amount of data that would be available, it limits the amount of information that you're going to see. And they call it the ADS-B traffic hockey puck, because it looks like a hockey puck dimensionally, three-dimensionally in the space. And that space is, TISB is plus or minus 3,500 feet from your current position and 30 miles around you. Okay, for ADSR, it's plus or minus 5,000 feet, so that altitude is extended. Okay. For ADSR, which is the 1090 ES to the UAT signals. So if you've got an aircraft that's outside of this puck, okay, not that you'd see it probably at 30 miles away, but you're not going to see it until it comes into that airspace, or to that airspace around that aircraft. Okay, can I receive traffic information about aircraft that are not ADSB equipped? Yes, we just talked about that. Of course, those are aircraft with transponders in it. That's another requirement. These aircraft must be equipped with a transponder, otherwise there'd be no altitude information that would be sending it out. And it wouldn't be accurate as far as what altitude it's at. And TISB requires an ADSB out signal. So you might be in a situation where you've got one of these, ADSB receivers in your aircraft. But unless your aircraft is equipped with ADSB out, you won't trigger the TISB system to receive that information from in the system. It's designed that you have to have an ADSB out in order to get the ADSB information with TISB. And so you might be in a situation where you've got an aircraft in that ring or that hockey puck of coverage that you have that has ADSB. And when you don't have ADSB, that would trigger you receiving that signal as long as you stayed in that hockey puck of distance around that aircraft that was ADSB equipped. So as every aircraft in rural airspace, in other words, required ADSB airspace, required to be equipped with ADSB out? And in general, the answer is yes. However, there are exceptions, like with everything else. Gliders, balloons, antique aircraft, and aircraft with inoperative or malfunctioning ADSB equipment.
Could you define antique aircraft, please?
Those would be aircraft without an electrical system.
Okay.
If it was originally manufactured without an electrical system, it's not required. But if that aircraft had been modified with an electrical system, then they would have to have ADSB installed if they wanted to fly in ADSB rural airspace.
If I may ask, what happens if an aircraft has, say someone buys a Piper Cub and returns it back to factory condition, taking out that system? Does that still count as an antique aircraft, or because of the history of it once having the electrical system, it now must have it?
That's a good question, Adam.
Because obviously restorations on these aircraft are getting more and more common now as more get older and get, abandoned.
I think if the aircraft was type certificated without an electrical system and you restored it to its original certified status, that you would not have to have ADSB equipped aircraft. Does that answer your question?
Absolutely.
Okay, all right. Can I receive traffic information if my aircraft is not ADSB out equipped? I've already sort of talked about that. You have to have an ADSB out transmitter in order for the receiver to work in areas to get TISB, because it needs that ADSB out trigger to enable TISB to your aircraft, the way the system's designed. And air-to-air ADSB traffic may be received directly via ADSBN. So unlike TISB information, which is those aircraft that are not equipped with ADSB but have transponders, aircraft that are ADSB equipped can talk, directly to each other in ADSB. And then you've got space-based ADSB or SBA. And those are for the aircraft that are equipped with 1090 extended squitter ES, 1090 ES aircraft. And they have what they call diversity transponder systems with antennas on the top and the bottom of the fuselage so that the signals can be sent up to the satellite-based receivers. They're very similar to the ground stations that, you know, the system is just that they're satellite-based. So let's talk about some ADSB installations. An ADSB out transmitter alone isn't sufficient to meet the requirements of 14 CFR 91.227. An ADSB out transmitter must also be connected to a compliant position source. GNSS, Global Navigation System, or GPS is another term, Global Position System receiver. The FAA recommends that WAAS GPS that meets the performance requirement of TSO C145 or TSO C146. Those are standards by which the WAAS GPS receivers are designed and are certified by. And then units readily available that meet these requirements. And avionics vendor offer standalone GPS receivers or packages them with ADSB transmitters. You may have an equipped aircraft with a WAAS GPS navigation system, and that may be compatible with an ADSB receiver. It depends on the ADSB manufacturer that obtains the STC, supplemental type certificate for that installation, because they have to prove that it meets all the requirements for what they call latency, which involves their intercompatibility between the two systems, to be able to talk efficiently and within time limits that are required for the system. And that's all laid out in that 91.227 regulation. And it talks about mixing and matching GPS receivers with ADSB transmitters in the field is not permitted because you have to prove their compatibility and that this, as a system, it meets the requirements. And so all your ADSB manufacturers will list those compliant combinations of WAAS GPS receivers and the ADSB systems. This is a point of contention, is that all ADSB installations in CAR certified aircraft, Part 23 aircraft, and Part 27 certified aircraft are major alterations. They're not minor alterations. They're considered major alterations because you are changing the limitations of that aircraft. You're actually extending limitations to operate in the ADSB rule airspace. And that's what makes it required, or it makes it a major alteration. So it needs to be accomplished in a 337 with an IA or repair station signature on it. The other requirement is that you actually have a pilot's operating handbook. It can be just simply one page that basically says that the installed ADSB out system has been shown to meet the equipment performance requirements of 14 CFR 91.227. And it has to be added to the aircraft flight manual or pilot's operating handbook. It's required to be carried on your aircraft. You get an ADSB system and you don't have that note in your POH or your AFM, get it in there. It's an actual requirement. If you're ramped, you could be found not compliant with the regulations, the requirements of the regulation. Another requirement is that it must be verified that it does comply with the requirements. And there's basically two ways that you can do that, either by ramp test equipment, where you've got a repair station that actually has equipment that is able to test and make sure that the transmitted signal is meeting all the parameters that are required by 91.227. Or another option is that the system is checked by what they call PAPR, which is a performance requirement, a flight check. But anyway, there needs to be an entry in your system that shows that the installed ADS-B out system was shown to meet the equipment performance of requirements of 14 CF section 91.227. And really there's just two means to do that, either by test equipment or by performing the performance check, the flight check.
Is that PAPR, that flight check, the same thing that people were doing when they were getting the rebate and they would fly and do the boxes and circles and all that nonsense?
Yes, exactly.
Okay, all right.
The reason why they have those requirements is that they want to make sure that the system, first of all, the GPS receiver that is supplying the information to the ADS-B isn't masked due to its installation in the fuselage. I've seen where installations on some of those wingtip ones on some aircraft with the drooping edges of the wings, where at certain bank angles, due to the position of the GPS antenna, let's say on this side, it would actually, the fuselage would shadow it from the majority of the satellites. And therefore, you know, if you're making a turn, you're not going to be putting out GPS information. It's going to be lost. And again, that position information is updated 5 times a second, very fast. And if you drop, I think, I forget what it is. I think it's 4 or 5 satellites are required. You know, you always have a certain number in the air in order for it to, you know, have integrity, meet the integrity requirements. And so that's why you do the testing where you do the banks, you know, for a minute, right bank, left turn, you do a climb, you do a descent at certain power settings. It's important that you do that test because you're ensuring that the operation of that system has integrity for all those, you know, different performance envelopes that the aircraft would find itself in. And the most important area where you have it is around an airport, you know, where you're turning and you're climbing and descending, you know, or covered into a pattern. It's very important that the system works in all those different configurations. So it's a critical thing that that be accomplished. That doesn't apply. This is just talking about non-TSO ADS-B equipment being installed in experimental aircraft. It doesn't necessarily have to meet the TSO requirements, which involves not only the requirements of 91.227 for all the different parameters that it needs to have and meet, but the TSO also has like a lot of environmental requirements for vibration, humidity, temperature requirements, whereas a system that may not meet all those stringent requirements can be acceptable to be installed if it meets the requirements of 91.227, and there's a statement from the manufacturer that it does meet those requirements. For experimental aircraft, that's all that's required. This is a link to a database that contains all the GPS certified equipment and manufacturers for GA aircraft. You're welcome to go back and take a look at that if that's of interest to you. The ADS-B performance monitor. With ADS-B, they're always recording all the data. of the aircraft that are ADS-B equipped. So yes, you are constantly being watched. That's not necessarily watched, but it's all being recorded. The history is being recorded for all aircraft that are ADS-B equipped that are operating in the National Airspace System.
So when you say that they're all being recorded, is it being recorded just as the movements of X plane, or is it being recorded directly as your movement? And if you wanted that not to happen, would you be able to request that so that your plane is just notified as a plane? Or is it you have to exactly what plane it is and exactly what it's doing?
Well, part of the information that's outputted is your aircraft identify code. We're going to talk about something that de-identifies your aircraft. There's a means by which you do that. A lot of corporate operators do that, where that's not necessarily having a number that's identifiable by it, but a de-identified means of tracking it. So because a lot of this ADS-B information is available to anybody, and so there is a means of de-identifying the aircraft, but it's not to necessarily the FAA or to ATC, but it is to others that may be interested in mining the data about you.
And are you able to control then if it's just the FAA who gets access to that data, or is it public access?
It's public access to the information, just like FlightAware and some of these other programs are available. It is, at least that's my understanding of it. This talks, yes, this talks about performance monitor that's used for the original certification of equipment and post-installation checks, which I was talking about. It's something that you should do with your aircraft. It's pretty easy to do. One of the problems that occurs is when the call sign mismatch or CSMM occurs. What happens is the ATC will receive an automatic alert, which increases the workload, and these errors occur, and what they have the ability to do is sort of shut you down so that you're not seen anymore. We're going to talk about that a little bit more. In other words, if you use a changeable flight ID, some of the ADS-B systems allow you as a pilot to do that, make those changes to, for instance, an Angel Flight ID. And some of the ADS-B systems, like I said, have that ability, others do not. So it's important if you're going to be doing those type of operations that you look into the type of equipment that you're purchasing to make sure that that information can be changed by the pilot. Okay, this is what I was talking, Adam, earlier to you about. Was this PIA, a privacy ICAO address? And this is a means of de-identifying yourself. Again, you have to have a U.S. registered aircraft to utilize this system. 1090 megahertz ADS-B equipped only, and you can use a third-party call sign, and you must be operating in domestic airspace. And the PIA program enables interested aircraft owners to request an alternate temporary ICAO address, which will not be assigned to the owner of the civil aviation registry of the car. And this is the link to find out more information about that, so that your call sign wouldn't be sort of traced by somebody that you wouldn't want it to be. It's a privacy system. But again, it only applies to 1090 megahertz ADS-B equipped aircraft. It does not apply to the UAT aircraft. Okay. Anybody got any questions about anything that I've talked about so far? Everybody's good?
I had just one quick question, and I thought you might just discuss it, or at least tell me what your thoughts are. Some of the ADS-B out transmitters come equipped from the manufacturer with what's called an anonymous mode.
Okay.
Are you
I
familiar?
am not familiar with it.
Well, a good example is the Garmin GDL 82.
Yeah.
Okay.
And now the way I understand it is, you wouldn't use that if you were going to go into, say, Class B, but if you were just flying and you didn't want to have, say, public, say you didn't want to have someone tracking.
Right.
Well, you could go ahead and be in full compliance because it gives all the necessary data except aircraft identification. But of course, if you went into Class B airspace, for instance, I mean, you would want it on. But if you're just going to be transiting, say, the perimeter, you could run with it in the anonymous mode.
Wow, Jim, that's good information. I didn't realize that capability was available.
Yeah, it's and the GDL 82 is an out-only unit, but since Garmin put it out, I know that they're not going to put out something that shouldn't be used.
Correct. Yeah, that's a good point.
I ran into the same thing. I installed the GDL 82 and read up on that anonymous, and it's my understanding, and I was going to ask that or later, but it's my understanding exactly what Jim said. You're still, as far as N number, that goes away, but you're still identified in the ATC system as an aircraft, and all the necessary information is there.
Right.
But as far as people like it makes it more difficult.
Sure, they just see you as an unidentified aircraft.
Yeah.
Yeah, that's good. That's a nice feature. So Jim and Dan, I understand. Then I would understand that once you went inside the Mode C veil or inside required ADS-B airspace, you'd have to turn that off. Is that correct?
Yeah, that I don't know. Maybe that was the same question Jim had. I'm not sure the requirements or what the expectation is, but I know there was a setting and there's a switch you can incorporate on the GDL 82 that you could just flip the switch and you're in, quote, anonymous mode. What that means, I don't know.
I tell you what, I'm going to look into that. And
I have a question as well.
Go ahead, Eric.
I just would want to know where the FAA's position is on the use of handheld ADS-B devices such as the Pilot Aware Rosetta and Sky Echo.
Is that an ADS-B in only system?
I believe it's ADS-B in. I'm just wondering where the position is on that.
ADS-B in would be, and it's a portable device.
Yes,
it's
the one you put on your aircraft and you get on your iPad. To
yeah, it's a portable electronic device, and the FAA doesn't restrict it. There is a restriction though. You cannot have ADS-B out, a portable ADS-B out system. That is illegal.
Is there is it just because of the potential unreliability or the potential use of a portable system? You could use it without having the plane, or is it just because of just because the fitted system is more reliable?
Right. In order for it to be putting out information, it's got to be a certified system, or a system like an experimental aircraft that is installed and meets the requirements of 91.227. The manufacturer has to produce a statement and has to do the testing that shows that it meets the requirements of the order.
Yeah.
I had in my earlier Comanche, I had the GDL 82, and as I understood it, to change the identity of the aircraft, like when I do angel flights, to put in the NGF 1150, that's my angel flight number, you have to do that with software, basically on the ramp. You can't do it in the air as you're flying. So it's a matter of, bringing your laptop out there, hooking it up to the unit and making the change. And of course, when you're not flying Angel Flight, you have to turn it back into the normal N number.
Right.
I got around that actually. I fly with the N number right at this point, and I simply put NGF 1150 into the comment of the flight plan because it has to be IFR flight plan anyhow. So the controllers know that I'm doing an Angel Flight, but they talk to me by my N number.
I gotcha. That's a practice that helps you to still, for the controller still to prioritize you, right? Is that correct? I understand Angel Flights.
It's not so much priority. They do give you a little better handling, put it that way. It's not so much priority.
Is that much in the same way that if you had a flight school aircraft, you might have, I don't know, whatever your flight school was called, one and, as a call sign? Is that the same? So what you do with the Angel Flight, you would do the same with if the flight school had, custom call signs rather than using the N numbers? Or is that because it's a commercial operation, it would be a completely different banner?
Well, with the Angel Flight stuff, I mean, the N number is my aircraft, but my Angel Flight number, the reason we all got numbers was because of the TFRs, particularly like when Obama was done on Martha's Vineyard. If we are identified as pilots, is our individual pilot number. I can be in any airplane I want, flying with that Angel Flight identity, and air traffic control and security knows who I am and that I've been qualified.
Okay, fantastic.
Robert, I do have a question.
Sure, Robert.
Regarding the installation and use of ADS-B, are the military aircraft required to have those? Because I fly around some MOAs, or are they exempt? And my concern is, if somebody's coming along at 400 knots and I'm doing 120, that's a pretty big difference in speed. So is the military required to have this ADS-B information?
I don't believe so, but I don't know for sure. I know that the ADSR system would work in that case.
I ran into the
Or
same thing.
TIS-B would work, I should say. Go ahead, Dan. I'm sorry.
I was going to say, I just recently asked that question. I don't remember who I got the answer from, but I think the answer was the military is exempt from the ADS-B. So when it comes to mixing military with civilian, it's the old school rules, with the old school transponder.
Right.
And
go ahead, Dan.
Yeah, just flying through MOAs, you gotta, especially even more now that you gotta have your head on a swivel. But not too long ago, I had the ADS-B in on my plane, but I kept my Xeon, I don't know if I'm saying that right, on the dash because it was new and the transition was going on. And targets were showing up all over the place on the Xeon and nothing on the ADS-B. And finally, I could see them out the window, A-10s flying all over the place. So they were exempt. And I've asked that question, I think just a couple weeks ago. And I think the answer was they're still exempt. I'm not sure if that's just forever or maybe there's just more of a leeway for them and down the road, maybe they will be. I don't know.
I know that the military equipped with what I think it's called IFF, Identify.
Yeah.
Friend or foe, which operates at 1090 megahertz.
Yeah.
And similar to the transponder systems that we operate with. And I believe that the TIS-B would pick that up, but maybe not. But I also believe that the military has the ability to shut that down.
They do, yeah.
So that they can't be tracked. And they may be conducting operations where they have that shut down.
Yeah.
And so, yeah, they are, I believe that's correct, that they're exempt. Is that anybody got any more questions about that? All set? All right, I'd like to move on to some ADSB installation issues and information about that. So this is a post-installation performance statistic that back when this presentation was done, it was or put together, this is what it was a couple of years ago. And this is just all this yellow disparities here show areas of non-compliance. And this particular aircraft had a problem where it was communicating. The GPS in the system was not meeting the requirements, and it was showing up all these little glitches on this. And Pete, I'm going to ask you to jump in just a minute here.
Okay.
And show what you showed me earlier today.
All right.
So mode 3A issues, no code transmitted. In other words, the your ID code that you put into your transponder isn't communicating to ADSB, or there could be a disparity between the UAT or the 10.9 or the UAT and the code put into your transponder. Missing partial incorrect flight ID is something that we've seen as problems. GPS reception dropping out due to shadowing of the GPS antenna from the aircraft structure, or a VHF comm interference. And I did not include this ADSB flight and VHF comm interference test sheet that I put together based upon the advisory circulars for the certification of those systems in aircraft. If anybody's willing to or wants that information, that sheet, I can get that to Pete, and then Pete, you can maybe post it and send it out. Emitter category is another thing, and then mode SIK address. So Pete, why don't you, if you would, share your screen and talk through a couple of the ADSB PAPR reports that you've got, and just walk us through that.
Okay, you're going to have to stop your share so I can do it.
Okay, just a second. Get my cursor. There we go.
Oh, come on. There we go. All right. Okay, these are tracks that I got on flight tracking of planes, things that I did. And the reason I'm doing this is because not everybody realizes how much you can get from ADSB information. This was flying from Danielson over to another airport area. This is Southbridge, flying around that one. And then we messed around a little bit. Then we flew up to Keene and flew back down and went to the Putnam VOR, did a very nice little hold pattern, and flew back into Danielson. To be able to see all that post-flight is kind of neat, particularly if you're talking with your flight instructor. This is the lower part of that same run, but what I'm going to point out is that down here at LZD where we were landing, it lost us at 1,200 feet. We were too low, and taking off, it didn't pick us up until we were at 1,200 feet. But also on the bottom here, this is also very helpful information. The green line is our altitude all the way out. We were at 3,000 feet, then we went up to 4,000, and then we went back down to get near to Southbridge, really low down at Southbridge, back up, and then down to Putnam, to Danielson. And then the speed is all in the yellow. There's a lot of information that's available if you want to look back and see what you did. This is the flight that I did, an Angel flight from Bedford, Mass to Presque Isle, Maine. And again, you know, this is, we ended up going straight. It was beautiful. Right about here at the Peace VOR, we were given direct Presque Isle. That's one of the advantages of being an Angel flight. But look down here. There was an IFR flight plan. So the ADSB track has our flight planned speed and altitude. The altitude we were going to be at was at 5,000 feet, and the speed was around 150 knots. What we ended up doing was going out at 5,000 feet, then climbing to 7,000 because it was so bumpy. And you can see from the speed track what the wind was doing to us. The wind was from the northwest, and it was bumpy as all get out. And you can see that in these kind of information. When I came back,
So that information that's displayed there as far as airspeed is ground speed. It's
correct.
not airspeed, it's ground speed.
Yeah, that's ground speed. Coming back, Bob actually slapped my wrist on it just now. Coming back, I forgot to turn on my dimmer switch. I forgot to turn on. The wingtip strobe is connected to the navigation lights. I forgot to turn them on. So coming from Prescott, which is way up here, this is where I remember to turn them on. And so that's where I started getting my ADSB information out. So this is a VFR flight. I went direct to Gardner and then direct down. And you can see, again, I was flying at 8,500 feet on the way down with a nice sort of crosswind, almost tailwind. And then at Gardner, I turned south, went down a little bit lower, and picked up a whole lot of tailwind. So that you can see that in the speed. It's kind of neat to be able to look back and see all the stuff that you can do with that kind of thing. It's another one. Oops, sorry about that. This is CJ flying from Florida to trying to get to Texas. And she had a problem. She had a problem with their navigation equipment, the avionics, all that kind of stuff. She was flying at this lower straight line, 4,500 feet. But the ADSB was saying that she was flying at 11,400 up here. And the speed track was okay, but she was having all kinds of problem with the output of her ADSB. This will give you a chance to look at something. If you have a question about whether your thing is performing the way it's supposed to, this tells you almost instantly that, yeah, you got a problem. What she did was get it fixed. And here's the next piece that she did. It's only 10 minutes worth of flight because it didn't pick her up until there and lost her over here. But look how nice and flat it is. The speed is steady and the altitude is steady. This white area over here is because ADSB was assuming that it's the same. Whenever it loses you and then you picks you up again, it'll fill in the gap with that little white mark. And that's it. That's my done sharing.
Thank you, Pete. That was very informative.
Okay, you're up.
Okay, and I'm going to go back. I'm going to go back to share mine. Second. There we go. Should see my screen again.
Almost. There it is.
There we go. Okay. Here's a couple of depictions of air on an earlier report. They're having some signal compatibility between, or data compatibility between the internal system. So the performance requirements are that you must have an appropriate equipped aircraft, ADSB equipped aircraft for the airspace you're operating when you're operating in the 91.225 defined airspace. Remember that chart that I showed you earlier that showed all the different areas of requirements? And then your avionics must meet the performance requirements of 91.227. This is this ADSB performance request pepper service to verify your ADSB out system performance and to correct any identified problems as soon as possible. And again, that's found on this website right here. If you haven't done a flight check with the PAPR, I'd recommend you do it. It just validates that your system is operating correctly. and follow those. I will actually send Pete the flight test requirements that I've gathered together, which details all the configurations you want to be in to do the test. And I strongly recommend you do that to just, again, validate that your system is operating correctly. Last thing you want to do is be going in controlled airspace and your system's cutting in and out in a turn or whatever, and you're not aware of it. Another thing that I included with the test, especially with ADSB systems that have their own GPS receivers built into them. My experience when installing WASH GPS receivers or any GPS receiver is that there are certain frequencies, VHF COM frequencies, that are harmonics to the GPS signal, namely 121.2, I think it's 0.225, and frequencies close to that. You multiply that frequency by 13, so the 13th harmonic of that equals the GPS signal. And the same thing with 131.3, I think it's 325 or thereabouts. You multiply that by 12th, of the 12th harmonic is a GPS signal. So what you have is you got the GPS signal, which is minute, microwatts, as far as the received signal, and you got a VHF COM transmitter that's transmitting, 10 watts or 20 watts of power that has these side lobes or harmonic frequencies that can be generated by the transmitter, or actually the number one culprit that caused GPS interference, VHF COM interference, was not the comms themselves, but actually the 121.5 megahertz ELTs. What I found was that oftentimes, if we had a problem, if we just disconnected the antenna from the ELT transmitter, it would fix the problem. And so you think, why would that be? And what it was the tuned tank circuit in that transmitter of that ELT. The physical or electrical characteristics of it would cause those harmonics to be re-radiated through that system and out so the antenna, the ELT antenna, would receive it and then re-radiate these harmonics out. And the signal strength of that noise that was generated was much greater than what the GPS signal was, the little GPS signal. And so what would happen is you transmit on these frequencies by keying your mic, on one of these frequencies, and if you're having your GPS has the ability to monitor the signal strength of the receiver, and you can see the different satellites it's tracking. And when you go to key the transmitter, we'd see all 7 or 12 or whatever it is of those track signals just go flat. And in the WASH GPS receiver, the GPS receiver would flag. And we're like, oh man, and that was one of the certification requirements for WASH GPS or an IFR GPS, is to do that test. Now, I have not seen in any of the ADSB manufacturers a requirement to do that test. I believe it's because if it doesn't have its own internal GPS receiver, that the WASH GPS receiver for the navigation system already had that test accomplished. However, those that have the self-contained ADSB systems with the GPS internal to the system, I haven't seen where they require that, and I don't understand why they haven't done that. I've even talked to National about that, and they just said, well, when we wrote the rule, it wasn't, or wrote the guidance for it, it wasn't something that we included in there. I said, well, that could be pretty important. If you're transmitting one of those frequencies and all of a sudden your ADSB cuts out because you've got VHF COM interference in support, it's important to know that. And on that test sheet that I'm going to give to Pete, I included those frequencies and how to perform that test. Again, you want a system that has integrity. You don't want to cut out in a flight critical time. You want to be seen. You want to be seen, especially by larger aircraft or other aircraft out there. This is something that I was talking to CJ earlier about, ADS-B no service aircraft list, NASL. NSAL is a function available within ATC automation systems that restricts processing of data transmitted by aircraft with ADS-B equipment exhibiting hazardous or non-compliant behavior. Remember in the depiction of CJ's flight where they were having the air with the ADS-B system, what was happening was one of the data lines from the blind encoder to the transponder was not making good contact on the back of the transponder. Thus, it was causing those deviations from, well, what were you at, CJ? 3,000 feet, and it jumped up to 11,000 feet or 11,300 feet.
Yeah.
And that's what that was caused by. And so when that situation occurs, if it continues to occur, ATC doesn't need you that. They need you to have you operating, so they've got this ability to shut you down as far as what they look at. The thing that would be disconcerting is if you had an aircraft that was operating at that erroneous altitude, all of a sudden was getting that ADS-B information, they'd be looking, where's this aircraft? Where's this aircraft? You know, and could be really put at angst due to a failed system. You know, they could be really nervous about the situation that would be in there. So this NASL system enables the FAA to keep potentially false or misleading data from reaching the controller's display. Aircraft on the no services aircraft list will not receive TIS-B or ADSR services. Public ADS-B performance request includes NASL status information. So if you apply for a PAPR, you're going to see the status information. If you're on the list, and then aircraft on the NASL will typically be notified by mail or may be subject to flight restrictions per use of aircraft condition notice. In other words, you may be visited by a local FSDO and put an aircraft condition notice on your aircraft stating that, hey, your ADS-B system is not performing as it ought to be. Restrict your flight into those areas, ADS-B areas. So let's talk about ADS-B maintenance and recurring maintenance requirements. So what are the recurring inspection requirements? Is it like a transponder that has a 2-year biannual recertification requirement, or for IFR, you know, the static altimeter transponder check? No recurring inspections are required. You say, well, why is that? I mean, you would think that, hey, this system should be tested. And the fact is that no, there's no requirement. And so it's unlike the transponders and associated barometric altitude biannual certification requirements of 91, 413, and 211. There's none required. The 91, 411, 413 inspections still remain, and you've got to get those checked every 2 years because the barometric altitude could be a problem, or the communication between the transponder and your blind encoder could be the problem, or your encoding altimeter in your aircraft. And the other thing is that that your ADS-B system is always monitored. It's continually being monitored. So that at any point you may check your ADS-B system integrity by performing that public ADS-B performance request, that PAPR, as we talked about earlier. So ADS-B operation when requiring maintenance. So let's say your ADS-B system's down and you need to fly into an ADS-B required airspace. And you can request deviations from the rule, and it must be to ATC facility that has jurisdiction over that concerned airspace. Requests may be made anytime, and I want to note that these requests are subject to ATC discretion. In other words, they don't have to let you into their airspace. It's their discretion whether or not they're going to let you in, and especially in high traffic times. They may say, look, you can't come in until after so many hours, you know, or to such and such a time when things are not as busy. So software updates, you know, many of you may get a GPS software update or on your navigation system, or recommended to improve some of the characteristics or performance of it. It's very important that you do this only with the concurrence of the ADS-B STC holder. So let's say you've got, I'm not going to mention any manufacturer, but let's say you've got an Avidyne navigation system or a Garmin GPS navigation system. And you're using that WASP GPS receiver from that navigation system with the ADS-B. Well, you can't upgrade that Garmin or that Avidyne navigation system software unless the ADS-B, your ADS-B manufacturer has approved that level of software. So you got to be careful when upgrading your navigation or your WASP GPS receiver software to make sure that you're all of a sudden not stepping out of compliance. And it depends. And I just go on to say, in a self-contained GPS ADS-B transmitter, the ADS-B manufacturer determines certification requirements and specifies so by maintenance instructions. And separate GPS ADS-B transmitter installations, the holder STC, typically the ADS-B manufacturer, makes a determination of what GPS software versions are approved. So getting close to the end here, we're going to look at some ADS-B web resources for aircraft reporting wrong ICAO addresses. Go to this link right here. These are a list of the TSOs that are applicable to ADS-B, advisory circulars for the operation of ADS-B, the airworthiness approvals of ADS-B out systems, and this AC, which applies to the airworthiness approval of ADS-B in system. If you're interested in digging into it this far, into deeper, the ADS-B technical information, installation information, there's a job aid that's available on this link right here, which is detailed right here. And it's a job aid that goes into not only ADS-B, but if you're installing any avionics piece of equipment in an aircraft, it tells you whether you can do it by field approval, whether it must have aircraft certification office, ACO approval, whether it must be done by an STC, and it details for all the different avionics installations. It's a pretty useful tool. Maybe not for you as pilots, but mechanics or somebody that's proposing to do something that's out of the ordinary. It's a great tool that defines all that information. Just like to just briefly touch on the unequipped aircraft again. In order to be considered for ADS-B, a deviation authorization with ADAPT, all this ADAPT thing, it's something that really doesn't apply to your operations. It's more for something for the airlines. Let me make sure I'm not confused here. Sorry, apologize. No, this is, I'm sorry, I was talking about something else. This is for the ADAPT. It's for an aircraft that does not meet ADS-B. If your ADS-B system is down, you've got the ability to go on here and request a flight, but you must meet the following criteria. Aircraft must be equipped with an operational transponder and operational altitude encoder. This is to fly into ADSB required airspace. And your request must be submitted no more than 24 hours before the flight, and the request submitted no less than 1 hour before the flight. So you got to be in that window of time, and it's done here. That's a means of requesting a deviation authorization. The site, FAAsafety.gov, or excuse me, FAA.gov, go equip ADSB has got all this information that's been presented here tonight. And then finally, if we got any questions that we haven't covered already, we're going to spend some time here going over any questions you may have. Well, that's good. I mean, if we don't have any questions, that's awesome.
Oh, I do. How do I get off the naughty list?
How do you get off the naughty list? I'm gonna have to get back to you on that, CJ. That NASA list.
Yep.
Okay. I'll get back
I'm
to you on
definitely
that.
on it. They're like, our system has screened you out because you're making us, you're giving us erroneous data, and they said, oh yeah, if you're causing our system to throw errors, it'll block you.
Yeah.
I have a.
The other.
You back
Well, the other question is just.
Go ahead. CJ, why don't you continue, CJ, and then George will get to you next. Okay.
Yep.
Okay. So the other question is, when ATC was trying to figure out, we were showing that our ADSB was working.
Sure.
And so I think it was Tallahassee very nicely asked other aircraft in the area. They had one that was 23 nautical miles ahead of us, and they asked if they could see us. They couldn't, but another aircraft paralleling them to the east in the same direction could. And so the other question would be, why would some aircraft be able to see us and others not? Our ADSB equipment apparently was working fine. It was our transponder that was, well, you know, who knows? There was enough weird stuff going on. But it sounds like, you know, are different, do you happen to know if different ADSB equipment has different filtering capabilities? Is that what we were running into? Why would one aircraft say, yes, I see them, and the other would say, no, they're invisible?
Right. It depends on you know, the altitude and distance that they are from you. What was the altitude and distance? So it could be a configurable thing. You know, and one aircraft had a configure for looking out further away from the aircraft, or maybe a wider altitude band than the other. Is one thing.
One was 23 nautical miles ahead, and the other one probably was more like 30 nautical miles away and to the right.
Yeah.
How about difference in altitude?
What's that, Pete?
How about like going back to the hockey puck, difference in altitude?
Yes. Yeah, that's true. Yeah, that's right. Yeah.
I have a question because obviously we spoke about CJ's erroneous ADSB data. If you had a TCAS fitted aircraft that was near at the same altitude that her data was recording that it was at, would that TCAS or that ADSB data have shown that she would be in a potential collision with that aircraft? And what is the what is the process when you have a near miss on a technology but not actually in real life?
Yeah, that's a good question, Adam. Well, first of all, in CJ's case, the problem was the altitude information that the transponder was seeing was erroneous due to a poor connection, we believe, on the back of the transponder. So TCAS system would see that, because that's what the way the TCAS system works. It uses a transponder system for not only the you know, the radio information or the heading at which the aircraft is, but also the altitude relative to their own. And so, yes, they would have been seeing the air also. And their TCAS could have been going crazy if it happened to be in that, zone where a TCAS, a traffic alert, or, would be a call out in a TCAS system. Or worst case, could have been an airline with a TCAS 2 system, and not only a traffic advisory, but an actual,
Because they might report.
Sure, definitely. That would be a really bad scenario.
They might report that they had. Yeah, they might report that they actually had a near miss of a couple hundred meters, or
the
anything if
aircraft could
CJ
have
was flying.
been diverted,
Yeah.
from the TCAS system, where it automatically, says, immediately climb or descend, to avoid a collision. And that would be something that the ATC would definitely be calling you about.
Is that something then that the pilot or owner of the aircraft would directly get in trouble for, or would you just be told, yeah, fix that before you fly next? Like, is that something you could end up being fined and or punished for if your system is failing in that way?
Well, that's a good question. And again, you would think in that scenario that the FAA, with its compliance philosophy or compliance program, would pursue it in a fashion where, let's say CJ, who would be willing and to be compliant and get it fixed, okay, wouldn't necessarily be, process. The compliance program would be what would be followed first. Now, if CJ had a situation where this kept occurring, let's say she got it fixed and then it came back and they had another occurrence that occurred, and maybe 2 or 3 times down the road, then the FAA would come in with probably an enforcement in that case. But for a simple mistake like this, 1 time or even maybe a second time, but if it was a recurring thing, then the FAA would have to pursue, making it right because it's unsafe. And sometimes we do run into individuals that are not willing to be compliant with the rules. And in that case, we do have the ability to, for the safety of the airspace system, we have the ability to conduct enforcements, But the first decision that we make is to make sure to see if the individual is willing, and capable of making the correction. And that's our first step that we make with the FAA. Nowadays, it used to be that I think at least some in the FAA were more of an attitude, I've got my black hat, and as soon as a non-compliance, with a rule is exhibited, they're out there with their guns ready to violate or fine or do whatever. But that's definitely not what the FAA has currently promoted, or has is what we're to do as inspectors, safety inspectors. We want to promote an atmosphere and a culture among us where we share information, share data, so that we can make it safer. And it's very important that relationship is established in a trustworthy manner, and we call it just culture. Everybody makes mistakes. We're all human, and everybody's going to make a mistake from time to time. And that's the way we want to look at it. We're all human. We all have brains. We all make mistakes. At least I do all the time. Yeah. All right.
We all do.
Yeah. Who else? I think it was George had something.
Yeah, I'm looking at that UAT, the Universal Access Transmit. Now, we also talk about TCAS. How many traffic systems are there? And they are not always reading the same thing. Like he said, and when we report having traffic to air traffic control, we'll say, we have them on TCAS, but it's ADS and it's UAT and it's not TCAS. Does that make any difference at all?
Good question, George. Well, basically you got TCAS systems, which are equipped with the corporate aircraft or the more expensive aircraft. And they work by transponder.
Yeah, we used to have TCAS before the advent of ADS,
Right.
or even GPS.
And large aircraft are still required to have TCAS.
Yeah.
They're still required to have TCAS. Even though they have ADS-B, they're required to have TCAS. They're not required to have ADS-B in.
We're speaking out of class when we say we've got them on TCAS. We don't have TCAS.
No, you don't have TCAS in your aircraft.
Yeah, it's
typically.
it's just like saying we have Kleenex.
Right. Yeah. Actually, you'd have ADS-B information, or maybe TIS-B.
Right. Yeah.
Remember, TIS-B was around before ADS-B was here. They had the extended squitter trend 1090 ES, like the Garmin GTX 330. When it first came out, used TIS-B before ADS-B wasn't deployed, and used the TIS-B system as it exists today. But that system still is, active and still used in those situations where you've got aircraft without ADS-B, but they have transponders, and then that information is relayed up with the ADS-B system, and then that TIS-B system is.
But more and more aircraft have traffic advisory on board, so
yes,
I think the aviation world is a better place.
Yeah, definitely. Yeah, definitely.
But we need to make sure our equipment is compliant.
Yes, and that's where that PAPR comes in. That PAPR ability, you got the ability to validate your system. Just it's Pete. It's not really hard to do. Correct? Have you actually gone and done the test?
Yeah.
Pete, can you hear me, buddy?
We pulled PAPRs on 7654 Papa a couple of times. And the first time was when we installed the Sky Beacon and discovered that we had some dropout, or not some dropouts, but it was a really, really helpful tool because we could keep pulling it until we knew we had it right.
Yeah. Yeah, there's no, as far as I understand, there's no restriction on how many times you can use it. You can keep using it and use it as much as you feel you need to do to ensure the integrity of your system.
Yeah, it's a good
that has
go fly.
Pete, I didn't hear you. What was that? Could you speak up?
It's a good excuse to go fly.
There you go.
It's actually kind of fun.
Yes. Yeah.
Yeah. One thing that may be of interest, and I'll try to step out of the room here. I called, so some of you may remember that a couple of weeks ago, a couple of guys from ATC gave a Comanche Zoom, including Hunter Newser from Fort Worth Center. And since I happened to be in Fort Worth Center when I had this problem, I texted Hunter and I said, hey, can I ask you a question? Can you look at my flight data track on ADS-B in your center and tell me whether my transponder is working properly at the moment? And Hunter, who happens to be not just a, an Fort Worth Center guy, but also a Comanche 250 restorer and a pretty fair wrench and an avionics guy, takes a look at the flight track. And I asked him one other question. It used to be that civilian radar did not provide an altitude readout, but in diving into it, because as we're trying to troubleshoot my situation, which had so many possible factors leading to the situation you could see when Pete shared his screen with the sawtooth thing that showed us jumping back and forth between 3,000 and 11,000.x. I said to Hunter, I'm trying to figure out whether I can use the flight aware track log data to help troubleshoot what's going on in the airplane. When you have me as a primary radar target, do you have altitude? And because I said, when I read about it, it looks like military radar does and civilian radar does not. And Hunter said, to the best of my knowledge, almost all facilities in the US are now mil-spec. But he said we still, even though, and so that would imply that the more expensive, more complicated military radar systems, because so many times they're handling dual duty, they're handling military facilities as well as us. But he said, even so, we do not accept that as viable altitude data for our civilian traffic. And so no, as far as I know, if it's showing altitude and it's not showing as coming from ADSB, that's coming from our radar, and therefore you are reporting to us your altitude correctly. So it looks to me like your transponder was working during the 10-minute flight track that Pete, that smooth one that you showed afterwards. He said, to me, this means you are reporting properly. And in fact, when I called into Fort Worth after Memphis lost us and all of our radios crashed, and I was like, oh my goodness, let's go back to the old radio. Fort Worth said, yeah, radar contact. And when your radar contact, they're seeing both your primary and secondary meaning your transponder encoding, altitude encoding, et cetera, is working. So we're still in, I'm still thoroughly confused as to what's going on, frankly. But, it seems to be working, but.
Well, the transponder mode C information, okay, is not only put out by the transponder, okay, but the ADSB system receives that barometric altitude and rebroadcasts it out. So there's two barometric pressure outputs out of your aircraft in an ADSB equipped aircraft. Your transponder.
Okay, one from the transponder and the one from the ADSB out, retransmitting your transponder. Okay. How does the blind encoder, which obviously sits there encoding at 29.92, interact with the rest of the system?
Well, do you have the Sky Beacon?
Well, the blind encoder apparently just talks to the transponder. But yes, we have the Sky Beacon.
Right.
But how does the blind encoder interact with, like in our case, the old narco transponder?
Yeah, well, see, again, you got the old it depends case with ADSB systems in general. But in your case, okay, with the Sky Beacon, okay, the Sky Beacon actually receives your transponder transmitted signal, okay?
Yep, by monitoring the voltages on the wires.
By monitoring your transmitted signal, okay? And it decodes that information and then rebroadcasts it on ADSB. So that's the way it works. So if you've got, as I believe in your case, a glitch in the connection between the blind encoder and the transponder, the ADSB has no means of knowing that. It's just going to re-radiate whatever the transponder puts out, so they'd be in sync together. Now, in another case, let's say you've got a different ADSB system where it's the information from the blind encoder is sent directly to the ADSB receiver, and it's not using the transponder to get that information. In that case, the transponder could be putting out one piece of altitude information, and your ADSB another, if there was, for instance, a poor connection at either the transponder or the ADSB system. So I'm trying not to confuse you, but that's another possibility, but not in your case.
Yep. So just to throw one more piece of strange data into this, what does anybody happen to know? Because I didn't, So here we're going along. ATC says we're seeing you at jumping between 3,000 and 11,000 X. And then at one point they said, wait, we're seeing you at both altitudes. And the implication, although I'm not sure that this is correct, is that they were seeing us at both altitudes at the same time. And I then tried to log into my Sky Beacon. So with ATC's permission, we recycled everything. Because I was like, I don't know if I'm supposed to recycle this stuff. And I'm pretty sure based on their phraseology that they wanted me to wait for them to tell me. to turn that stuff off. I don't know what the rules are on
Yes,
it, but so do we need to, so if we've got something glitchy, do we need to have them tell us to turn off our transponder? Or, you know, they told me to, okay, move it from altitude to on, and then we agreed that they would have us recycle the transponder. And now I'm like, okay, now we need to recycle everything, but I'm supposed to not have any of this stuff off because the new ADS-B rules are it always has to be on. So then I was just like, well, I'm going to do whatever I'm told in this area because, right. But at the end of the day, they came back and said, we're seeing you at both. She's like, wait, no, I'm seeing you at both. Because I said, we were trying to troubleshoot the fact that we were seeing the airplane at both altitudes. And then she's like, wait, I'm seeing you at both. I got the mental impression that she was looking below my readout on her screen and saying, oh no, I actually see you at both 11,300 and 3,000, as if, and I got the impression I was transmitting two conflicting altitudes, but I don't know if that was correct. Is it possible that is, can you do that?
Sure.
With all those systems?
And what would be a scenario that I could see was an intermittent connection. You know, that was jumping back and forth real fast.
Yep.
You know, faster than ATC could follow it. You follow me?
Yep.
So
their computers could, but they couldn't.
Right. Their system is looking at a window of time, you know, or time this way, let's say.
Yep.
And during that time frame, it's doing, you know, jumping back and down due to an intermittent connection, you know, on the back of that transponder. Then I could see where they would be shown both altitudes. You know?
Robert and CJ, you want me to put that screen back up again?
Sure.
Sure. The one that's really jaggy is the one that goes Jax to Memphis. It's the one in the middle. But either one shows it.
Okay. Am I still sharing my screen? No, right?
Nope. Pete just took over and he's
Pete's got it.
sharing
Okay, good.
his.
Good.
And so that, that's not where it got really bad, but you can see it peg high there. So it's reading correctly at the beginning. In theory, at least, we're low enough.
Here's the beginning. Just the beginning.
Yep. Yep. And the peaks are not, you can see the really, really rapid jumping up and down where it fills in completely solid. Pete, you don't have to, yes, right there, and the next one that look like castle turrets, if you will, or towers.
And I would say that's probably when they were seeing both at the same time during that time frame.
Yep. And does this, so if we lay out our possibilities of a problem where we have either unless all of these are happening, a failing transponder, or thanks James, glad you were here, a failing transponder, or a bad intermittent connection, or a loose breaker floating around contacting other things, or a gray code rewiring that either also is intermittent or miswired. Which ones fit this and why? This is more of an aviation maintenance technician question probably, but this is like your final exam question.
Well, not all the transponder, the blind encoder communicates altitude information to the transponder one of two ways. One, digitally, or you wouldn't have a glitch or jumping altitude. It'd be either, you know, unless the altitude where it's digitally done, and you wouldn't have this scenario like you've seen. The other way is via 12 lines, code lines they call them, that they call gray code. And what you may see is, let's say you've got one line that's not functioning, whether it be the transponder or whether it be the blind encoder. And depending upon the combination of required bits of information, depending upon what altitude you are at, it may be fine with this open water. And then when you get to an altitude where it is required to be at 3,300 feet, you know, or whatever it is, and that one line is missing, it may look at that point up to be, you know, 11,300 feet just due to the code requirements of that reporting. But I believe in your case, it was due to intermittent contacts because you were staying at one altitude, right?
Yes, that's correct.
Yeah, so I think it was due to an intermittent contact on the back of that transponder or connection somehow, intermittent connection.
Yeah.
I find it interesting how it starts off by spiking and then it spikes quite a lot. And then for some reason it seems to hold itself at the higher altitude, the one the aircraft isn't actually at.
Mhm.
And I find that because if, from what CJ was saying, they actually had her on both altitudes. But if that was the case, then that is kind of the risk for the aircraft above and a risk for the aircraft on the same altitude who might think she's actually 5,000 feet above her when she's not.
That's correct.
Yep, they were awfully nice about it, but knowing that they were both seeing their equipment would be saying that our aircraft was in a very, very steep descent. And so that might, I don't know what the system's alarmed for, but you know, they certainly sounded like, are you okay? Because, you know, some of the readings they were getting probably looked consistent with some terrible thing where like a wing fell off and, you know, where we had a bird strike and took off our tail or something, you know, they would be. Anyway, so there was that, and then there was our, you know, our looking scary to other airplanes and to ATC trying to maintain separation. So it was, they were awfully nice. I was doing my best to give them, you know, good data and to cooperate, and they were really trying to help me. It was a good interaction, but boy, what a mess. So, and they were radio, you know, they were, as they handed me off, they were letting them know what was going on. And then we were trying to collect, you know, information, and it was just this news that, oh, they just had an avionics upgrade and they're having some trouble. A lot of sympathetic people, I guess, we're not the first airplane to fly through on a fresh avionics upgrade with a few issues. But yeah.
Ron Richmond here. With regard to recertifying
Go ahead, Ron.
an ADS-B, you said it doesn't require recertification like the old transponder. In my case, I got a Garmin unit which took out the old transponder totally, and it has the symbols for a transponder built into the Garmin. Does the altitude part of Garmin having to do with what looks like an old transponder have to be recertified on a regular basis?
Yes, good question, Ron. Yes. Every 2 years, you're required to do the 91, 411, and 413 tests if it's an IFR operating aircraft.
Right, and even though it's an ADS-B radio, you still have to have the transponder part of it recertified.
That's absolutely correct.
Okay, thank you.
Yeah.
For anybody that didn't see this, Dr. Bonham, first of all, Dr. Bonham, thanks so much for putting that in there. He said he posted some updated links. He said the links have changed from the presentation.
Thank you.
So yeah, /go/ADSB equip redirects to. I'll grab that and mail it to you as soon as I can.
I'm making
I
a
hope
note of that.
nobody else
Thank you,
runs
Doc.
into my situation.
Okay, we're coming up on 2 hours worth of presentation here, and I'm thinking I would like to end the recording or somewhere near this point. Robert, thank you for stepping up. This was actually put together in 2.5 days, this whole thing. So it's a major effort. It's worked out great. the Zoom will continue because right now we have Piper Comanche as a co-host twice. So the Zoom will not die when I get out of it, but I'll be leaving right now so I can stop the recording and go take care of getting it ready to go back on the internet tomorrow. So at this point, I'm going to end the recording.